All right. So thanks, everyone. Thank you, Mr. Sudhanma and Dr. Suresh, for your gracious presence today. So I'll just take 10 minutes before the demos and before we get into the AI session from Ajay. I'll just take 10 minutes to talk about something very few people, very few of us in this room, in this country, get to hear in plain language, right? Quantum computing. Not about the headlines. We know every other day, Modi's government is launching quantum computing centers all across the country. Not about the hype, not about the physics, but what quantum computing is, why it matters right now, and why a city like Mysuru should care about it. So let's go, what is quantum computing? Every computer that we have ever owned, right, the one that I have in front of me, the phones that you have in your pockets, are all, built on one idea, bits, the good old bits. A bit is a light switch, essentially on or off, 0 or 1, one state at a time. And this has been the whole game for 70 years now. With quantum computing tries to dismiss that whole philosophy. It tears up that rule book. Its building block is not a bit. It's what we call a qubit. And qubit does not behave like a switch. It behaves like nature. It's strange, it's layered, and full of possibility. So what we are going to see in the next 2-3 minutes is going to define how it would rewrite the next decade of computing. So quantum computing is, if you want to describe it in one line, it is about possibilities. It is not about certainty, it is about possibilities. You see, classical computing, the good old computers that we still work with, are all about certainty. And quantum computers work on the idea of possibility. Now, a bit is a light switch, like I mentioned, one state at a time, one answer at a time. You know whether a file is open or not. A qubit is more like a magical dimmer, right? It has every shade between on and off at the same time until you measure it. Right? We'll not go into the details of today's session. We'll have a series of sessions to talk about fundamentals of quantum computing. But just to give you a flavor, now think of it like you walk into a library and you want to find a string in thousands of books. A normal computer would go to each aisle of the library, open up the book, scan every page of the book and try to find that, whereas a quantum computer would open every book simultaneously, end to end, and read every page simultaneously, and at the very end hands you the right answer. So the key principles of quantum computing are threefold, right? So you will hear a lot of this in the next months and years to come. Quantum computing is built on three fundamental principles. Superposition, right? Think of it like a coin spinning on the table. You have a coin spinning on the table. While the coin is still spinning, you don't know whether it's heads or tail. Right, so you cannot say it is heads or tail. It is both in a way. It is both heads or tail until you measure it, until it collapses on the table. Only then it will fall into either heads or tails. A qubit is like a coin that is spinning until you look into it and exploring many possibilities at once. The second one is entanglement. Entanglement is like, you have two qubits that are linked to each other, and once they are linked, whatever happens to one instantly affects the other. Now it's like if the two qubits are in the same room, they're still linked. If the qubits are separated by a galaxy, they're still linked. So Einstein called it spooky action at a distance. We do not fully understand why nature allows this phenomenon, but we fully embrace it in building quantum computers. We know how to use it. That is entanglement. The third one is interference. So everything is seen in the world of quantum computing as a wave. Every possible answer to a problem is a wave, and a quantum algorithm is essentially a choreography. That makes wrong answers cancel out. Over a period of time, the wrong answers, which are waves, become smaller and smaller. Their amplitude becomes smaller and smaller. They diminish out. Only the right answer continues to live, enabling you to solve the problem. Again, these are very high-level, abstract, complex concepts. We are working as a forum to simplify them and try to make them easy to understand in our day-to-day life. So why quantum computing now? Now, quantum computing has been in discussion for over 30, 40 years now, and suddenly in the last 10 years, there's so much action. That's because qubits have become very stable. Now, 10 years ago, when you wanted to do a qubit, they were very unstable. They would collapse in microseconds, not allowing us to build stable computers. Qubits have become very stable now. We have technologies, superconducting technologies, that operate at very low temperatures, making it possible to have stable qubits. The second is, there are a lot of errors when you are working with, at the level of quantum computing. We have figured out several, mechanisms in which we can correct these errors. Quantum correction, error correction has significantly improved. In the last 5 years itself, there were 400 papers from various scientists around the world just focusing on quantum error correction, making it now very easy for us to cut down the error. Third and a very important thing is we have started seeing full stack software around it, right? So we have started seeing IBM roll out Qiskit. We have Google's Circ. We have Amazon's Bracket. Now you can write quantum computing code like you write Python code today. Like Mr. Sudhindra was mentioning, you can just go create an account on IBM Quantum Cloud. They give you 15 minutes, and then after that it is $4 per second. It's quite expensive, but now you can write quantum code and build quantum programs using libraries like this. Fourth point is that all the tech giants realize these, right? So now we can build quantum computers. It has moved significantly. Error correction has improved. They're all in the race. Every tech giant, IBM, Google, Microsoft, Intel, they're all pumping in billions and billions of dollars. They have teams of hundreds and hundreds of PhDs who specialize in quantum physics and mechanics, all building quantum computers. So this is no longer a side project for them. This is a mainstream business for them. 5, I think this deserves a mention. Google unveiled a chip called Willow just last year. In 5 minutes, this chip is able to do a calculation that would take the world's most powerful supercomputer today 10 septillion years. That is greater than the age of the universe. So that is the power of quantum computing. One important myth that we want to solve is that quantum is going to replace all existing computers. That is not how it works. So quantum computer is a specialist. It is not a replacement to existing computers. Quantum is good only in certain things. Where it really wins are very complex problems that are hard for classical computers to solve. Drug discovery is one area. So simulating a molecule exactly the way nature has built it. Material science, designing the next battery, the next fertilizer, the next superconductor. Optimization at a national scale, things like logistics, power grid, financial portfolios, and most importantly, cryptography. The race for quantum computer has become so fast and quick, primarily because of cryptography. Mr. Ajay Chaudhary mentioned yesterday on NDTV that if China can build a 20 qubit quantum computer today, they can bring down the Bombay Stock Exchange tomorrow. Right? They can crack all algorithms, all security, all safety in one day, bring down the Bombay Stock Exchange tomorrow, which is very important, which is why you see a lot of government initiative around strengthening the quantum network, quantum computing infrastructure. Where quantum does not help, now, anything small, anything routine, anything general purpose, anything that your phone or laptop can already do, that is not going to be replaced by a quantum computer. You'll still continue to use WhatsApp on a classical computer. You'll continue to watch Netflix on a regular computer. Quantum computer is too expensive to watch a movie on. Now, here is where it gets interesting, like Mr. Sudhindra mentioned. Now, this is the slide that this community will mostly focus on. And everyone in this room has used ChatGPT, Gemini, Claude. AI is having its moment now. This year, next year is all AI's moment. But AI has a ceiling. It learns from data, and the bigger the model, the more brutal the training cost is. Quantum expands this space that AI can search and train on. Now, it does not replace AI, but it supercharges AI, essentially. Now, what does it actually look like? Now, training giant models that are costing companies billions and billions of dollars is going to get faster and cheaper with quantum computers. A brand new field is going to emerge called quantum machine learning. Algorithms that are native to qubits are going to emerge very soon. They've already started coming up. Optimization, routing trucks, pricing flights, recommending what you want to watch are all going to happen through quantum computers. And my favorite is the discovery loop. Right? MIT Technology Review mentioned this. Now, AI today can design a drug using all the GPU power, but quantum can simulate it exactly. And then the AI would learn from the result, and then they can run in a loop. And a discovery engine that we never had is going to be possible with the intersection of quantum and AI. AI plus quantum is not going to be 1 plus 1. It's 1 times the other. It's essentially multiplicative, and that multiplication is going to decide what the next decade of technology would look like. A quick look at what India is doing with respect to quantum computing. 6,000 crore rupees, the National Quantum Mission announced in 2023. 8 years, 4 hubs, quantum computing at IISc. Communication, quantum computing communication at IIT Madras, sensing at IIT Bombay, materials in IIT Delhi. So all this is a reality today. These are areas where government has already invested in. 1,000 kilometers of secure quantum communication, 17 startups, and recently, in Andhra Pradesh, a new quantum valley is being stood up in Amravati with plans for the India's largest quantum computer, a 133-bit qubit machine, a physical building on Indian soil running India workloads. The question is, which Indian cities will be on that field, with Amravati? Which brings me to why we are here tonight. Mysore has missed on many frontier tech opportunities, like Mr. Sudhindra mentioned, and an IIT that never came, a triple IT that never came, the National Forensic Science University went somewhere else. So AI and quantum are the next big anchors, and we want to catch it ahead of the curve. We don't want to miss out on it. What Mysore has today, a strong educational base. We have universities, engineering colleges. We have a growing pool of engineers, founders, R&D talent, a quality of life advantage when compared to other tier 1 cities. Recognized innovation assets. We have KTech at CFTRI, we have LARI, we have KDM cluster and ESDM cluster. Policy tailwinds. Karnataka LEAP, the National Quantum Mission. That is the opening, and Mysore Quantum AI is stepping into it. And 3 reasons that really matter: sovereignty of what we build and own, talent. India's next great engineering generation is in this room, and we don't want to miss out on something that is emerging for the next decade. And ecosystem. So it is ecosystems that build cities into large tech hubs. So we want to focus on building strong ecosystems together. So this is what Mysore Quantum AI is setting out to do. Not to compete with Bangalore, not to chase the Silicon Valley, but to put our own city, Mysore, our state and our people on the map. Because the next decade of computing is being written right now, and Mysore is going to write it for the world. Thank you very much. Thank you.